Revit MEP. So Revit MEP is something which a mechanical engineer, a civil engineer, and an electrical engineer will collaboratively work together to create some facilities in the building. Okay, so in order to create some features and facilities in the building, we have Revit MEP. So in our civil engineering syllabus, actually we have already come across about plumbing in detail, to be precise. Okay, it's not that we have just seen an overview. What we would be thinking is that we only had a lab in the first year, which is related to plumbing, but we have already dealt in detail with plumbing, and then mechanical part that is called as HVAC, which is nothing but heat, ventilation, and air conditioning.
Mm.
That part comes as an elective paper for us in seventh semester. Heat, ventilation, and air conditioning comes as an elective paper in the seventh semester.
Yes,
In
sir.
the electrical, we're not gonna go deep into the core. We're just gonna see how to model electrical components in Revit. Okay, this is how the whole syllabus is framed for Revit MEP.
Yes, sir.
Then MEP, M stands for mechanical, E stands for electrical, and P stands for plumbing. First, we are going to see how to draw the mechanical components and how to route the mechanical components. Okay. The
Okay.
mechanical components, if you have to understand what is the schematic behind that uh, whole routing, whenever somebody asks you to do a routing, what you have to do is you have to first understand the schematic of that particular structure. You have to understand the schematic of that particular structure. So understanding the schematics means only then you will be able to do a proper routing in the given building. So to
Yes, sir.
understand the schematics, I have you need to just copy this note, but I'll share the screen.
Okay.
There are certain components that will be used in Revit MEP. Okay, so well, in order to understand the functions of those components, we'll compare it with the water supply that is there in our house. Okay, so
Mm.
how do you get water supply in your house in Nepal?
Concept.
Hello,
Yes, sir.
how do you get water supply in Nepal?
Means how means through pipes means
Through pipe, and where is the source?
from water tanks. There will be one water tank, big water tank in the city. From
Okay,
there.
so that is for common. That is common for all the houses.
Yes,
What if
sir.
the house is not able to get access to that water tank? What if they are not able to get that access to the water tank?
I didn't get this, sir.
No, not all the houses will have access to that water tank, right?
Yes,
Am I right?
sir. Yes, sir. We have like hand pumps and motors, all this thing.
Okay, so then motor, when you have that motor, for that, from where the source of water is coming?
Groundwater.
Groundwater. Okay, very good. So groundwater is the major source, and what this motor does is it sucks the groundwater
Yes,
and
sir.
it takes it to the water tank. So water tank in the sense the smaller water tank that is there in our house. There the water is being stored, and from that water tank, how do you transport the water to different rooms?
What's the
From the groundwater, motor transfers the water to the water tank, and from the water tank, how do you distribute the water to different rooms?
through the with the help of pipes, sir?
Pipes. And does the pipe directly release the water in the bathroom, or do you have
No,
any
we
other?
have a valve, sir.
We have a valve. Very good.
Yes, sir.
What does the valve do?
It stops. It's releasing the water and stopping it. It works, sir. It's working as like stopping
That
and
is
releasing
called
the
as
water.
valve. What do you have in the bathrooms,
A
which
shower
decides
and
when the water should open and when the water should close?
yes, sir. It's called valve, no, sir. Like it's controlling the water.
Walls will be there near the water tank. I'm asking what do you have inside the bathrooms? Inside the bathrooms, you don't have
S-
walls.
Yes, sir.
What do you have?
Shower.
A shower directly. The water keeps coming in shower. Huh?
No, sir. It's
Then
through the pipe now only.
yeah, through the pipe only.
Mm.
So let us say, like you said, I have a water tank, I have a pipe, I have a shower. Now, if water is going to come, it keeps coming, right? How do you control the flow in the shower?
Yeah, that's why I told you like valve with the help of
Wall
valves.
will be there in the top of the terrace. I'm
Oh,
asking you, how will you control the? So you every time you want to switch off the shower, you'll go to the terrace and turn off the valve.
no, sir. Actually, I don't know the name, sir, but there will be one. Yes, sir, there will be one inside the bathroom. Also, there will be one controller. I don't know the name exactly.
You don't know. You don't know what is a tap.
Yes, sir. Yes, sir.
So you have a tap, right?
Yes, sir. Yes, yes.
So now this is the actual schematic of a water being brought from a source point, that is from the groundwater. It is being distributed to the house. Now, whatever water we use for bathing, washing, and all that, what happens to that water?
What you are
You're
asking,
listening.
sir?
You're listening, or what are you doing actually? Because every question I'm repeating two
No, sir.
times.
Actually, sometimes it's getting buffering. That's why I'm getting confusing, and
Okay.
sound is coming too slow. That's why, sir.
What happens when you use that water, right, for bathing, for washing, for cleaning purpose and all? What happens to that water, that used water?
Oh, it's stored in the septic tank and
How does it go to the septic tank then?
through the pipe only, sir.
So to the pipe, before the pipe, through which it enters the pipe, through which component it enters the pipe.
There'll be holeness inside the bathroom.
What is it called?
I don't know, sir name.
It's called floor drain.
What, sir?
It's called floor drain.
Okay.
Okay, through that it enters the pipe, and that pipe will get connected to the septic tank, and some of the water, like the water that we wash the utensils and all that, that will go to open ground. Okay, this
Yes,
is
sir.
a schematic of a water supply that is happening in a house. Now I'm going to compare the same schematic to an MEP, to a mechanical component. Okay,
Okay. Yes, sir.
so mechanical means we take care of HVAC in a building. We take care of HVAC, we take care of lifts, we take care of escalators. All that is taken care by a mechanical engineer in a building. Okay, in an airport building, in a metro station building, or in a power plant, in a factory, wherever it is. These are the components taken care by an mechanical engineering. It
Okay.
takes care of the HVAC. So in this Revit MEP, we are going to talk about HVAC here. HVAC is heat, ventilation, and air conditioning.
Mm.
HVAC means heat, ventilation, and air conditioning. Can you see the screen in front of you?
Yes, sir. Interessant.
This is what is called as HVAC.
Okay. Yes, sir.
Okay. Now, that bore or the motor, which is sucking the natural groundwater, okay, that process is done by an equipment called air handling unit.
Air
That's an
handling.
air handling unit.
Okay.
See, like you have to understand what is written in this notepad. I
Hmm.
have written the schematics, and I have compared that schematics with the schematics of our house, where the
Yes, sir.
water is being sucked from the ground and it is being taken to the water tank. From the water tank, it is being distributed to the individual rooms, and the water which we use there is taken again through pipes and it is going to the destination. So the same schematic, I'm comparing it with the HVAC. So now the bore or the or motor is there now, which sucks the natural water. That function in HVAC, it is done by an equipment called air handling unit.
Okay.
Okay,
Hmm.
and then there's another equipment called VAV. So that is called as variable air volume.
Okay.
What it does is it collects all the groundwater that is sent by the motor, and it stores itself in the water tank.
Yes, sir.
Stores itself in the water tank. So that function is called as VAV. That equipment is called as VAV, variable. Now, like, say it acts like the water tank. So in the don't think that VAV stores water. It actually just the function of a water tank. Just like the way how water tank stores the natural water obtained from the motor, in the same way, what variable air volume does is it collects the air, cold air from air handling unit and it stores before distributing it to the rooms. Okay.
Yes, sir.
Next, we have ducts. So ducts are nothing but it acts like a pipe. Okay.
Hmm.
There are two types of pipe in our schematic. Remember, we one is freshwater pipe and another one is drain water pipe in our schematic. In the same way, one duct, what it does, duct means pipe only. Okay, it's similar to a pipe.
Hmm.
What a duct does is it carries the cold air from one point to another. It carries the cold air from one point to the another. So if the duct is carrying a cold air that is freshly released from an air handling unit, it has not been used by any rooms, then that particular duct is called as supply duct. A duct
Okay.
that carries the fresh cold air is called as supply duct. And the same way, a duct that carries the air inhaled and exhaled by us, or the duct that absorbs the heat in a room produced by human beings and materials, if it is sucking that air and if it is getting it out, then it is called as return duct.
Okay.
It's called as return duct. Exhaust duct means it sucks the waste air from the room and it just releases in the atmosphere. It doesn't connect to any equipment, whereas return duct connects to an equipment.
Hmm.
Exhaust ducts, they don't get connected to any equipment. You can see it in restaurants and all. From the kitchen, if the hot air has to be released, they have these ducts and all that.
Hmm. Yes, sir.
Okay. Then the function of a tap, you have the taps in the bathroom, right?
Hmm.
That
Yes, sir.
controls the flow of water inside the bathroom, whether the water should release or not. All that will be controlled by a tap only. In the same way, just like a tap, a diffuser acts. Supply diffuser. Supply diffuser is a component that decides how much cold air comes inside that particular room, produced by
Okay.
the AHU. Okay.
Hmm.
So AHU, air handling unit, acts like a bore that absorbs. So now I'm going to explain the functions of each and every mechanical equipment. Now you understand what it is, right?
Ah, yes, sir. Yes, sir.
What an air handling unit AHU does is, it absorbs the air in the atmosphere. It
Hmm.
absorbs the air that is there in the atmosphere or in the environment. It absorbs the air, takes the moisture content in that air, compresses that air by using a condenser. Okay, and then that air, that normal air, becomes a cold air. Okay, we have that refrigerants and all that. It becomes a cold air. It becomes a cold compressed air. So
Hmm.
when a cold compressed air is flowing in a confined um, space, that is called as, let's say, even that cold air will be called as a fluid only. Cold compressed air flowing in a compressed environment can also be called as a fluid. Okay,
Okay.
just like the way water, a cold compressed air is also considered as a fluid. Now, what happens is that air handling unit compresses that air, produces a large amount of volume of air, and that large volume of air produced by the air handling unit is taken by a supply duct to different rooms. Though a duct carries the cold air to different rooms, it is a diffuser that decides how much air should be thrown into that particular room, just like the way a tap does in a bathroom. Okay. Though
Okay.
the water is being uniformly carried in a pipe, it is the tap that decides how much flow or how much speed the flow has to be when it comes to filling the bucket in the bathroom. Okay.
Yes,
And
sir.
then what variable air volume does is, if it is a multi-story building, let us assume it is a multi-story building. Okay, each and every floor will have a variable air volume. What this does is, it acts like a water tank. What it does is, it collects the cold air that is coming from the AHU. It collects all the cold air that is coming from the AHU. Then what it does is, it actually, after that, after collecting all the air, it decides when and how the cold air has to be supplied to the
Okay.
individual rooms. Okay.
Hmm.
And the function of the pipes, the responsibility of carrying the cold compressed air is taken care by ducts. Okay, you have supply duct and then you have return duct. In the same way, the responsibility of a diffuser is how much volume of air has to be thrown into that particular room. That portion is taken care by a diffuser. And
Okay.
what a return diffuser does is, it absorbs the water air that we have released by breathing out. Generally, in an air conditioned room is closed, right?
Hmm. Yes, sir.
So whatever air that we release has to be ventilated out, right? That is by the return diffuser. Understood?
Hmm. Yes, sir. Yes, sir.
Okay. Now we're going to get into the topic software now. That's it.
Okay.
let's say when you join as an MEP engineer, right? When you
Yes, sir.
join as an MEP engineer in a company, or you're bound to do the work of an MEP engineer, let us say in a company. What generally happens is you will be given two scenarios to work. If it is a very big company like an MNC company,
Hmm.
you will have to do only the MEP part. You will not be responsible for doing the architectural part, or you will not be responsible for doing the structural part. All you have to do is you have to do the MEP part alone. Okay. So in some small companies, right, they'll recruit Aman for the talent of having all the three knowledges in Revit.
Okay.
So if they recruit you, they need not recruit an MEP engineer because you yourself know MEP. Okay.
Hmm.
So that is another situation. So if you're the one who's going to do the architectural part, the MEP part, and the structural part, means you'll have to draw the walls. You'll have to draw all the what to say. You'll have to draw all the MEP components. You'll have to draw the walls. You have to place the ceiling. You have to place the floor. Everything will be done by you. So for that, you have to know Revit architecture also, which you already know.
Yes,
Okay.
sir.
In sometimes what happens is in bigger companies and all, the MEP part alone will be done by you, and the architectural part will be done by somebody else, and that work will be given to you, and you have to insert that architectural file in your computer, and then you start working the MEP part alone. So
Okay.
that is another nature of work. Okay,
Hmm.
fine. So now what we are going to do is we are going to deal with. So let's say imagine you are going to get recruited in a small company. Okay, there you already know how to draw walls and all that.
Hmm. Yes,
So we are going to draw the walls, we are going to draw the floors, we are going to draw the ceiling, and then we are going to draw everything related to architect, and then we start with the MEP part. Okay. So for MEP, what I'll do is I'm going to choose the template file as mechanical template. I'm going to choose the template file as the mechanical template. So you have mechanical template here. Select that and click on OK. Select that and you'll click on OK.
yes, sir.
Okay. So now you can see the project browser here. The moment I choose mechanical template, you can see a difference in the template here. Right
Hmm.
there, project browser. You can see a
Yes,
difference
sir.
in the template. Okay, you have floor plan, you have ceiling plan, you have elevations, and then you have plumbing plans. Separately, you have each and every plan. Right now, we are going to deal with HVAC alone. Okay, right now we are going to deal with HVAC alone. Okay, let us see how to do that.
Okay.
We're going to deal with HVAC alone. So we'll see how to do that. So first, we'll draw set up the walls and everything. The structure that I'm going to take as an example is a marriage hall, and ventilate and air conditioned marriage hall is the one that we are going to do now. Okay, so in order to understand the concept, that will be easier for you. Okay, we are going to construct a marriage hall here. Okay,
Hmm. Yes, sir.
so what I'll do is I'll go to architecture tab. In the architecture tab, I'll go to build panel. I'll take the wall here. But you have to observe one thing. When you're in the mechanical template, right now I am going to do the HVAC part. So
Hmm.
I'm double clicking on HVAC floor plan 1. Okay. And then I'm taking wall here. I can draw a wall. No problem with that. But the problem is, after I draw the wall, after I complete drawing the wall, I'll not be able to select the wall. I
Okay.
need to be able to select the wall. So what I'll do is before drawing the wall, I'm going to change the top constraint to level 2.
Okay.
The top constraint to level 2. Need to draw a wall like this. Let us say 80 cross 70 or 80 cross 70 on a hall like this. So let us say this is a marriage hall or party hall, function hall. Okay.
Okay.
Now what I'm going to do is I'm going to draw the floor and ceiling part. Architecture tab, build panel. You have the floor.
Hmm.
So you know all these things already.
Ah, yes, sir. Yes, sir.
So I'll finish it. Now, whatever I draw, and if it is related to architecture, I'll be able to draw it, but I'll not be able to select it. You can see that I'll not be able to select it.
Okay.
So by mistake I did something like when I'm drawing this wall and floor, I had to give a property, but I couldn't have completed the drawing. So now I'm in mechanical template. I'm not able to select it. So in that case, to make the correction alone, what I can do is, when you are in the floor plan, right, in the properties palette, you can see that there is something called diffuser. In the discipline, it is in mechanical. If you change it to architectural, you will be able to select the walls.
Oh,
Clear?
yes, yes, sir.
Okay, so right now I'm going changing it back to mechanical. In the properties palette, you have discipline, then you have subdiscipline as well. Okay,
Yes, sir.
fine. Next, what I'm going to do is I'm going to draw the ceiling now. I'm going to draw the ceiling now. Once again, once again, ma'am.
Okay, sir.
Okay. So now I'm going to draw the ceiling now. Before drawing the ceiling, I'm going to draw some rooms here. So a marriage party hall will have guest rooms. It will have a dining area, and then it will have restrooms, right? So what
Yes,
I'm
sir.
going to do is I'm going to draw certain rooms like this. Okay, rooms this side. Okay, I'm going to draw rooms this side as well. Okay, and then again I'll draw a dining hall of this length. Okay,
Okay.
then each and every room I'm going to draw walls like this. Okay, so I've drawn the walls like this. Next, what I'll do is I'll have these rooms. This is the sleeping area, this is the dining area, and these two are the restrooms. Okay. Now, what our objective is to place ceilings here. So I'll go with architecture tab. In architecture tab, building panel will have. In the building panel, will have ceilings. You can just place ceilings like this, or you can go to ceiling plan, and then you can see the ceiling being placed.
Yes, sir. Right.
So I'll keep placing the ceilings like this. Okay, we'll keep placing the ceilings like this. So after you do that, now we are going to start doing the MEP part. Okay. So today's
Okay.
class in MEP, first thing what we'll be learning a new thing is we'll see how to place the diffusers.
Hmm.
Okay. So when I
Yes.
say diffusers, it means one second now. Yeah. So the first thing that we'll be seeing today is we'll see how to place the diffusers. Okay. So when I say diffusers, you can relate it with the schematic here. So these are called as diffusers. So diffusers have multiple names. They are called as diffusers or air terminals. They all
Okay.
mean the same. They all mean the same. Okay.
Mm.
Put the heading as placing air terminals. Put the heading as air terminals.
Mm. Yes, sir.
Okay. So now we have to go to systems tab. Okay. Generally, the air terminals. Before we go into the topic, we'll see what an AHU looks like, what a diffuser looks like, and everything. So this is what an air handling looks like. Okay.
Oh, yes, sir.
This is what an air handling looks like. So what it does is it absorbs the air from the environment, condenses it, supplies it as a cold air. Okay, this is
Okay.
how an air handling looks like. And then this is how a variable air volume looks like. This is an variable air volume. So it will have it have a controller of how much air should go out and all that. Okay, so all this will be there. So this is a variable air volume.
Mm.
And
Yes, sir.
then this is a duct. This is what a duct will look like. Have you seen it?
Yes, sir. Yes, sir.
These
Recently, I
ducts
have seen someone in one side.
these ducts are actually hanging using a clamps here like this. You can see the clamps there.
Ah, yes,
Can
sir.
you
Yes,
see?
sir.
So those are called as duct holders. These are called as duct holders, and
Okay.
these are called as air. These are called as diffusers or air terminals. You would have seen this in the ceilings. It will be embedded in the ceiling. Have you seen this?
Ah, yes, sir.
These are called as air terminals. Okay.
Yes, sir.
Yeah. So
Yes, sir.
far, these are called as air terminals. So now we are going to place these air terminals on the ceiling. Now we know that the ceiling is placed automatically on 9 feet. If you see in the elevation view, keep it in a wire frame. You can see the ceiling here.
Mm.
And if you see the height of the ceiling, go to annotate tab, you have spot elevation. You know this already. You see the height of the ceiling, it is placed exactly on the 8 feet height.
Mm.
Now I have to increase the level here. So it can't be 10, so I'll keep it as 13 here. So then only
Okay.
we'll have some space to lay the ducts above the ceiling. Okay, so the
Yes, sir.
diffuser is the 8 feet height. Okay, now what I'm going to do is I'm going to keep it in ceiling view. Okay, I'll keep it in HVAC floor plan ceiling view.
Mm.
Okay, HVAC ceiling view I've opened level 1. In that, what I'll do is I'm going to place the diffusers now. I'll go to systems tab. Systems tab, you have HVAC panel. the HVAC panel, you have air terminal. Okay,
Yes, sir.
you have systems tab. In systems tab, you have HVAC panel. In that, you have air terminal. Select that air terminal, and then here you have an offset of 0. So when you are placing the air terminal, there are certain things that you need to take into account. You have to closely observe certain things. If
Okay.
you see the properties type, if you go and click on that instance types, right? So you
Hmm.
can see many types of diffuser here. You have exhaust grill, you have return diffuser, you have supply diffuser, so you have
Okay.
grills and all that. So right now we are responsible for keeping the supply diffuser. So I'm going to select this one, and then the next thing we have to take into account is the offset from the host. The
Okay.
offset from the host, or sorry, the offset from the level. So I'll have to give it as, if it is not, if it is in 0, you'll not be able to see the diffuser here. So you
Okay.
have to change it into 8 feet. You change it into 8 feet. So now you can see the diffuser. You have to place after certain distances.
Oh.
You'll
Hmm.
place the diffuser. So you'll place the diffusers like this.
Especially it's used in this commercial building, na sir?
Yeah, this is used in commercial buildings also. In India and all, it is used in commercial buildings. If you're going to work in projects from Gulf East and all,
Hmm.
then it will be used in residential buildings also.
Okay. Yes, sir.
If it is a Gulf, if it is a house in Gulf country, it is an apartment in Gulf country means
Hmm.
there you will use it in houses also.
Hmm. Okay, sir. Okay.
So you can select it. You can just mirror it. Okay, I've
Yes, sir.
selected it and then I've just mirrored it. So this is how you'll place the diffuser. Now what I'm going to do is I'm going to place supply diffuser now, return diffuser now. I'm going to place return diffuser now.
Okay.
Okay. So for that, I'll go to Systems tab. In Systems tab again, I'll go to HVAC panel.
Hmm.
In that I have air terminal. So I'll click on that air terminal here. So after you click on that air terminal, you have supply diffuser listed here. So you
Hmm.
have to change that to return diffuser now. We'll change it to return diffuser. Select it. And now I'm going to place return diffuser. Just like I said before, you have to make sure you have given the right elevation point here. So
Yes,
I'll
sir.
give that as 8 feet again. So I'm going to place certain return diffusers like this. For 4 supply diffuser, 1 return diffuser is sufficient.
Okay. So, what we have given the offsets 8 feet, it's the same level of ceiling, right?
Yeah, exactly.
Okay.
Now, next thing what we are going to do is we have placed the diffusers now. So, like in the schematic that I explained, the tabs are different. Now,
Hmm.
these tabs need to be connected with the pipe.
Okay.
Okay, these diffusers need to be connected with the ducts. Okay,
Hmm.
so let us see how to create the ducts. Put the heading as routing of ducts. ROUTING, routing of
Yes, sir.
ducts. Put the
Yes,
heading
sir.
as routing of ducts. Okay.
Yes, sir.
Next thing what we are going to say is we are going to start drawing the ducts now. So we'll go to Systems tab. In Systems tab you have HVAC panel. In the HVAC panel you have ducts here. Systems tab you
Let
have
me
HVAC
see.
panel, and in the HVAC panel you have ducts here. So
Yes, sir.
ducts can be classified based on the shapes also. You have rectangular ducts, you have square ducts, you have oval ducts. You have multiple shapes for a duct. So we'll see those
Okay.
shapes. uh, drop down, you can see the different types of ducts here, shapes and all that. You can change the shape whenever you want. Okay,
Okay.
so you can change the shape from here, whether it is an oval duct or rectangular duct or round duct. Okay, so
Yes,
now
sir.
I am going to deal with the rectangular duct. If I'm going to put a rectangular duct, I have to consider two things in it. One is the size of the duct, the cross section of the duct. So it is 12 inch cross 12 inches. Okay, you
Yes,
can
sir.
change the size by clicking on the drop down like this. You can change the size by clicking on the drop down like this.
Yes, sir.
Okay, and then the elevation is there, right? Middle elevation. I'll tell you what it is. I'm going to draw, keep it in 9 feet itself. I'll explain to you why a 9 feet can't be given. So if you're going to lay the duct on the height of 9 feet, you cannot connect it with the diffuser. I'll show you why it is.
Okay.
Okay. So they say it is a middle elevation. So what I'm going to do is I'm going to draw a duct like this. I drew a duct like this. So I'm going to take a section like this. In that section, if you see, you can see the duct over here. Okay. So when we say the middle elevation is 9 feet, okay, this point, this point is 9 feet.
Yes, sir.
Okay. Then the base of the duct is 8.5 feet and the top of the duct is 9.5 feet.
Yes, sir.
Okay. Now what happens is, let us say I'm bringing a duct from here to connect with this diffuser. Now what happens is, when you bend that duct here, no, there won't be enough room space for you because already the duct is like half. So you need some space for the bend to happen.
Hmm.
Okay. So in that case, what we have to do is we'll have to raise the elevation of the duct. You are getting the
Okay.
point?
Ah, yes, sir. Yes, sir.
Okay. So in this case, what I have to do is I have to raise the elevation of the point of the duct. So instead of giving it 9 feet, what I'll do is I'll change it to say 11 feet.
Okay. Yes, sir.
I'll change it to 11 feet here. Okay.
Hmm.
The same way, I'm going to draw some more ducks. So I'll again keep it in 11 feet. Now you can see both 9 and 11 will be there. You can interchange the heights whenever you want.
Okay.
So I'm just drawing a duck this way. Okay, like this. I've drawn the duck. Clear?
Yes, sir. Yes, sir.
Okay. Now, next thing what I'm going to do is I'm going to connect the ducks with the diffuser. I'm going to connect the diffuser with the ducks. What I'll do is
Okay.
I'll select the, I'll draw a duck like this. Draw a duck like this. I'll draw a duct like this. Now you can see it is connected.
Hmm.
Same way, I can connect this duct also by selecting the diffuser. You have an option called connect into. So when you
Okay.
select the diffuser, you get a panel called layout. In that layout panel, you have connect into option. Okay. So you
Hmm.
select that and then you place it on the duct here. So you can see that the duct has been connected. The same way, here what you can do is these are called as duct fittings here. This is a T
Okay.
junction, rectangular T standard, and then this is an elbow. These are all not called as ducts, they are called as duct fittings.
Okay.
Straight line is a duct. These are fittings that attach two ducts. Two
Hmm.
ducts. Okay, clear?
Yes, yes, sir.
So I want to make this instead of T, I want to make this into a four-way. I'll select it, and then you have a plus symbol here.
Hmm.
So when you click on that plus symbol, now it has become a
Oh,
four-way.
okay.
So again, you will take ducts from here, you'll connect it to this particular point, like this. Okay.
Hmm. Yes, sir.
Now here you connect it again. Now here the problem is that both these ducts are on a straight line, right? So what I'll do, I'll just draw it like this,
Okay. Yes, sir.
and then this one I'll just connect it with this particular duct. Okay. Now both the ducts are connected. Right. Now when you're working in MEP, now when you're working in mechanical or when you're working in plumbing, it is very important for you to have two views parallelly. So now this is a floor plan, right?
Hmm.
Going to open the 3D view. So what I'll do is I'll open the both the views parallelly here. So I need to have a floor plan window and then I need to have a three-dimensional window. What I'll do is for that, I'm going to go to View tab here. I'll go to View tab here. In that View tab, I have Windows panel. I
Okay.
have View tab. In that View tab, I have Windows panel. In that Windows panel, I have tile views.
Hmm.
In the Windows panel, I have tile views. Understood?
Hmm. Yes, sir. What is this, sir? Tile views?
So tile views. So I can see, you can see that the both the windows have been tiled here.
Oh, yes. Oh, okay, okay,
I mean,
okay.
you're actually not taking notes. No, you're just recording the video, and then after that you see the video, and then you'll take the notes. Huh?
No, sir. I'll send you the photos. I'm taking the notes
No, because
also, sir.
I actually am going in a very faster pace, but you haven't told me that I'm not able to take notes. I go
No, sir.
slowly outside.
No,
Why is
sir.
that?
Up to routing of dots, I've taken the notes, sir.
Uh,
Shall I send you the pics, sir?
no, no, no. My question is, I know in my experience, I know right in what pace I'm going, in what speed I'm going, right?
No,
So the
yes, sir.
speed
But
that I'm going right now will not be sufficient for you to take notes. So that's why I'm asking. If you're recording it, fine, I don't mind.
no, sir.
But
But
make
yes,
sure
I
you
have
take
taken the
notes after
notes
that.
also, sir.
Great then.
Wait, sir. I'll
Because I'm
send.
since you said that within this week you have to finish Revit MEP. Actually, I'm going a little bit fast. Okay, if you
Mm,
want, you can record it and then you can later on see it and then take notes also. No problem. Okay,
okay, sir. But I'm also taking the notes also, sir. It's
fine then. Fine then. Okay. Next thing, what I'm going to do is I'm going to connect all the ducts. Now we have to patiently select all the duct diffusers individually like this, and then you have to go to this layout panel, connect into, and then you'll connect it with the duct. Okay, we have to do this individually only.
okay.
You can't copy all the duct diffusers and connect it in a single thing.
Mm,
So you'll individually select all the diffusers, and then you will connect everything into this particular thing
okay.
like this. So the
This
moment they get,
paints, sir. This
yeah, tell me.
paints coming automatically, right?
Yeah, it will come automatically.
Okay.
For piping, it won't come automatically. We have to do a change that I'll teach you when you are doing plumbing. Okay,
Okay.
right now for HVAC, automatically it will come. If it doesn't come, you'll adopt the same method that I'll be teaching you in piping. Okay,
Yes, sir.
you have to adopt the same method. Now again, I'll connect these ducts again. So this is how you route the
Yes,
ducts.
sir.
So if you're not able to connect it, you can slightly move this side. Once
Okay.
again. So we have to individually select each and every diffuser and then we have to collect it place it in the we have to connect it in the ducts.
Yes, sir.
So when are you coming to Chennai? Hello.
Yes, sir. I'm listening, sir.
When are you coming to Chennai?
Let's see, sir. Actually, they didn't announce for the degrees. College didn't announce till now.
Mm-hmm.
Let's see when they will going to message us.
Okay.
After receiving the message, I'll call you, sir. Means when we'll come
Okay.
down.
So if you're coming, you can get the certificate for this also. So let me know priorly, okay, when you're coming and all that.
Okay, okay, sir. Your sound is not.
Yeah. I'm not talking. I'm just
Oh,
routing here. I'm doing the same method that I was doing.
okay, okay.
I'm not teaching anything new. So I'm just routing the leftover ducts like this. Okay. So I have routed all the supply ducts. You can see how they will be routed like this. Here, all the ducts have been routed on top of the ceiling. Okay.
Yes, sir.
Next, what I will, next what you are going to do is we are going to, when you are actually routing the ducts, right? One thing we have to keep in mind, it has to be economical routing. So you cannot run the ducts to a longer distance. So I'm just, for class sake, I'm just routing it like this. But when you're working in a live project, you cannot run the duct in a longer distance. You have to always go by the shorter distance. Okay.
Maximum 1 feet, sir.
Sorry,
Maximum the distance 1 feet or.
not the distance. This routing distance is there. No,
Yes, sir.
all this routing distance should be in such a way that it always uses the shortcut, not the longer path.
Oh, okay, okay.
And only the fabrication cost and will be less for the ducts. Okay.
Yes,
Now
sir.
I'm going to draw the return duct here. So you'll go to Systems tab. Systems tab, you have HVAC panel. In that HVAC panel, you have ducts. So
Hmm.
right now, what I'm going to do is I chose the duct. I decided what is the size of the duct, and I also decided what is the elevation of the duct. Okay. And then one thing we have to not forget to change. We have something called systems type here, and the systems type you have to change it into return. That
Okay.
systems type you change it into return. Now, if you see in this diffuser itself, can you see any difference among the supply diffuser and return diffuser? Do you see any difference all among the supply diffuser and return diffuser? I'm going to place a supply diffuser here. So I'm placing a supply diffuser here. So do you see any difference between these two diffusers?
Yes, sir. Symbol.
Symbol is different. So if it is one slash means it is return, and if it is
Hmm.
two slash means it is supply.
Yes, sir.
What are the difference you see?
What, sir?
What other difference you see?
The, there is no difference.
No difference at all. Seriously, you don't
No,
see any difference among these two.
no, sir. Oh, yes, sir. Yes, sir. Yes, sir. Arrow.
What difference?
Arrow, sir.
Arrow direction is different. For
Yes, sir.
return diffuser, the arrow will be inward direction, and for the other diffuser, you have it in one second, man.
Inward out. Yes, sir.
So the supply diffuser will be the arrow will be in the outward direction. So
Yes, sir.
the reason why I am telling you this is if you're going to an interview, they'll ask you to study a drawing. So you can study the drawing. You'll understand only if you know
Oh,
the study these symbols. Okay.
yes, sir. Thank you, sir.
Okay, now I'm going to draw the return ducts here. So return ducts in systems tab, you have HVAC panel. In the HVAC panel, you have ducts here. So in the ducts, you'll have to change the system to return air. Now I'm going to draw the return ducts here.
Okay.
So now the return ducts cannot collide with this particular ducts here. So what I'll do is I'm going to start it in level 11 feet. Okay. And then I'll change the height here to 12 feet. I'll
Okay.
change the height to 12 feet. Enter.
Hmm.
And from there, From here, it will go to 12 feet. Okay,
Yes, sir.
here it will go to 12 feet. And then from here,
Okay.
I draw it and I stop it like this.
Mm.
If you see it in 3D view, it will be, you'll have it like this.
Yes, sir.
Okay. Now, when you're routing it, you have to make sure you connect the return diffuser to a return duct and a supply diffuser to a supply duct.
Okay.
Okay,
Yes, sir.
and then you connect the supply diffuser into a supply duct. So now we have already connected the return duct into this thing. We have already connected the supply diffusers into the supply duct. Now we have to connect the return diffuser into the return duct. So now you can see, since I changed the elevation here from 11 to 12, you can see that actually the duct has raised 1 feet above.
Mm.
Now what happens if you don't do this is, you can see that the return duct will clash with the supply duct. So that shouldn't happen. That is the reason we are doing it. Okay.
Okay. Yes, sir.
Now we'll one by one select the return diffuser and connect it into the return duct
Okay.
like this.
Oh.
Since this is a simple marriage hall, we were able to easily do it. But if it is a complicated structure, you'll have to make sure you check with the routing settings here. You have to change the elevations constantly. You have to be very careful when you're doing that.
Okay. So for the design purpose, there will be certain codes or not?
Yeah, you have a code called Ashtray code, but don't worry, you will not be doing the design part.
Okay.
Just like the way a mechanical engineer cannot do a structural design, the same way you cannot do a design for HVAC, because you have qualified MTech or PhD professionals for that.
Okay.
For,
Okay.
for, for mechanical department. Your job will be only to do the routing part alone.
Oh, got sir.
This job is only called as MEP modeler. You have to understand the input and then you will have to draw the routing. But I'll show you how to design also, don't worry.
Okay. Okay.
I'll teach you that, but you will not be using it. So like this, you will have to connect all the diffusers and ducts. Okay.
Yes, sir.
And the last thing, what we are going to do is we are going to place a AHU. You have air handling units. We're going to place the AHU. Okay. Now
Yes,
what
sir.
I'll do, I'll keep it in floor plan like this. Okay. And then for placing AHU, what I'll do is I'll go with systems tab. The systems
Yes, sir.
tab, I have mechanical panel. In that mechanical panel, I have mechanical equipment here. So for placing the AHU, you'll go to the 3D floor plan view.
Okay. The mechanical panel then.
Sorry,
System tab mechanical panel. After that, what you said?
you'll go to mechanical equipment here.
Okay.
That mechanical equipment, you can see in the instance type, you'll have lots of mechanical equipments. You'll have boiler, you'll have air handling unit, you'll have VAV.
Hmm.
So all these will be there. In that, we'll go with air handling unit here. So you'll select the air handling unit, and then you're going to place it somewhere over here.
Okay.
Okay. So after that, I have to connect that AHU with this ducts here. So I'll select the AHU. Okay, I'll select the AHU, and then I'll go to layout panel. In that layout panel, you have connect
Connect.
into option.
Hmm.
Okay, so connect into, you have supply and then you have return. So I'll go with supply and then
Okay.
you'll select the supply duct here. So it will get automatically connected like
Okay.
this. And for return, you need enough room space for that. So I'm going to select the HU again, and then you have layout panel. In that layout panel, you have connect into. So you select that, and in that you'll go and click on OK here.
Okay.
So you're going to select the return duct. So it will
Oh.
get connected with this.
Yes,
Okay.
sir. Yes, sir.
So now the whole circuit is complete. So if you want to check whether if there are any disconnects, whether if I haven't closed anything, So I know where a disconnect is there. But if you want to, if you're not able to spot it, what you have to do is you'll go to Analyze tab.
Okay.
In Analyze tab, you have Check Systems panel. In the Analyze tab, you have Check Systems panel.
Hmm.
In that, you have Check Show Disconnects option.
Okay.
Okay, you have Show
Hmm.
Disconnects option, and in that, you'll select that, and then you'll highlight the ducts here, and then click on OK. So you can see that these 2 points are not connected,
Okay. Yes,
and
sir.
then here you have a disconnect. So the reason why you have a disconnect here is it says you have a disconnect over here. Now I have a diffuser. Select connecting to next. Still
Okay.
it is showing me that I'm having a disconnect. So I placed two diffusers, I guess. I think I placed two diffusers.
Stop. Okay.
Okay.
Yeah. Yes, sir.
So now the disconnect for overcoming this disconnect, what you'll do is you'll select the duct like this. You'll select the duct like this, and in that you have edit panel here.
Yes, sir.
Select that, and then you have the edit panel here. In that edit panel, you will go and click on this connect into option. In that edit panel, you will go and select the sorry, you will have that cap
Gap.
open and
Yes,
select.
sir.
You'll select that, and you can see that you will get a gap here. So now even that disconnect is also rectified.
Hmm.
Okay.
Yes, sir.
What you do is open Rivet and try to do a layout like this.
Hmm.
See the
Okay, sir.
note and try to do it. After you finish doing that, give me a message. We'll see the next topic. Okay.
Okay.
So far,
Now, sorry,
sufficient.
what?
Yeah, now only.
Okay. Okay.
Okay. Now the time is 10:30. Try to do finish it off before 11:15. Okay.
Okay. Yes, sir.
Yeah.
Okay. Thank you, sir.
Yeah.